everyone and welcome to Make Electronics. I have to apologize for not uploading in so many time. I had my final year exams coming and I had to study a little bit, but the exams are over and by the way I passed it. And today we are going to talk about very interesting subject. Many people asking the same question or a similar question to this. What is a motor driver and which one between the L293D and the L298N I should be using. Here I have two, actually this one, two ships, the L293D and the other one. Many people asking what should I buy, the first one, the second one, and is there any other motor driver I should be using. In this tutorial I'm going to show you the difference between the first one, the second one, and which I hope at the end of the video you will be able to choose which motor driver you're going to use for your motors, because well, driving this motor isn't the same as driving this motor. And let's get started. So here is small DC motor. I prepared two photos here so I can explain the role of motor driver. So for the ones who doesn't know what is a motor driver, as you might know, or if you don't, it's okay, we can change the direction of a DC motor by simply changing the polarity of the battery. So here we have minus and you have a plus. In case we wanted to change its direction, we can just simply change. We put here plus and here minus, so we change the polarity of our source voltage. Now this is easy task if you are just having a motor in your hand and you want to change its direction, but let's imagine you have it in an RC car or a fan or something. And well, a fan I don't think so, because normally it works in one direction, but let's say you have a system which you need to change the direction of your motor. You can you just open the case of where is your motor and change the direction? Well, you can do that. So here we need a motor driver that will help us changing the polarity of your motor. So here we have minus plus, it goes in this direction, but in case we change it, our source polarity, the motor will go in the other direction. I hope this was clear. So basically a motor driver permits you from changing the direction of your motors by just one button or something like that. So easy direction changing. So here I have the L293D datasheet opened, and I'm just going to make to talk about small things here, because I made a video about the L293D in the previous day, which I'm going to put the link of the video in the description. I hope you can go and see it to know it better. So if you don't know, the L293D can only deliver around 1 amps to each channel. As you can see here, 1 amps to channel 1, channel 2, and it can drive a motor with a voltage that is between 4.5 volts to around 36 volts. If we go down here, this is the chip. We have here 1 enable, 1 2 enable, 3 4 enable. Actually this one enable the output 1 and 2, which is 1Y and 2Y, and 3 4 enable the output of 4Y channel and 3Y channel. Basically, your motor will be connecting between those two here. First motor, here the second motor, and here you have the output, which is you're going to drive your motor with, commanding your motor if you wish. Here you have an input 1, and here input 2, input 3, input 4. So if you put here 5 volts, here 5, here low, will go in one direction. If you change it, here you put 0, and here you put the 5 volts, it will go in the other direction. But just make sure you don't open them together for the sake of not damaging your chip. Well, here you have VCC1, which is a 5 volt supply, as you can see here, because the chip can only work with 5 volts. Well, don't mix the motor voltage with the chip, because the motor's voltage is here, VCC2. Here it can goes from, as I said earlier, this voltage 4.5 volts around 36 volts, but make sure not to mix those two or you're going to burn your chip. Now this is all I'm going to say about the L293D, and I'm going to show you the chip in real life, and then we are going to talk about the L298N, and it's a little bit confusing for the ones who see it the first time, and I hope I can make it as clear as possible. So let's have a look on the L293D. Well, this is the L293D, as you can see here. That is the chip. I connected a motor to it. This is the input of the motor voltage, and here the second channel of the second motor. Here, as you can see here, I have enable 1, VCC ground, those two for the direction of the first motor, the second motor, and enable 2. Actually, I put here 2 10k resistor for the enable. Actually, I wanted to add 4 more, so if it's not high, it's low. So here I'm going to demonstrate the actual thing, the job, and I'm going to show you that it actually does what it should be. So here I'm going to connect it. Here, as you can see here, see direction 1. So if I now go to the other one, the other direction, so I hope you could have seen the changement of the direction. Maybe it is not so clear, but it actually changed the direction. I'm going to try making more clear experiment when I'm using the other chip. So this is all about the L293D. Now let's talk about this one. Wow. So let's have a look on the datasheet. So this is the datasheet of the chip. Here we have the through-hole mounting, and here surface mounting. So the L298, as you can see here, can deliver up to 46 volts to a motor, or actually 2 motors, which is huge comparing to the L293D. And the nice feature of it, it can actually deliver up to 2 amps to each channel, but if you want more, it can deliver up to 4 amps, but you need a special parallel configuration for that. You can just check it on the internet, or I'm going to actually leave a photo for it, for how you can wire up in parallel so you have more current. Here we have the internal schema in the internal block diagram of the chip. Now you need those two capacitors between the VS and the VSS. Here the motor voltage, the logic voltage, the logic is the same as the L293D, 5 volts. And here the motor driver, as I said, it can up to 46 volts. Now this 100 nanofarad capacitor will ensure that your battery will last longer. It can work without them, but it will just run out quickly, so you need them, and the datasheet said you must have them, so you need to have them. Now this is the confusing part. Many of you who saw this before, or the first time seeing this, they will say, wow, what is this? Okay, it's actually simple, and I'm going to explain it. Here we have a current sense A and current sense B. So here you have two options. One is to wire them directly to ground. It will work fine. The second one is to put a low resistance resistor, but it have a high watt resistor, so you can just put 2 watt resistor, but you can just put randomly any number, so you can add 0.5 or 0.25 for what reason? Okay, for this reason, in case you wanted to measure the current that your motor is drawing, so you have big system and it shouldn't draw more than 2 current for the sake of your motor or your device, or even for the sake of the motor driver, because if it's drawing then to 2 amps, it will go super hot, which actually for this specific chip you need a radiator, a heat sinker, which goes here. This is the hole to mount in it, and it should be something like this. But if it goes super hot, it can damage, get burned, something like that. So when you put, like, let's say you put a 0.5 ohm resistor and you want to check your current, we can use Ohm's law. V or U equal E multiplied by the voltage which you're going to measure using a voltmeter. Then if you want to go measure E, you can just divide your voltage by your ohms, and then you can have your current which you're drawing. So now let's keep explaining. So here you have output 1, output 2, output 3, output 4. Here you're going, it's output, so you're going to wire your motor here. First motor here, second motor here. Now this is VS, pin 4 is where you're going to put your motor voltage. It's, as I said, between 0 volt to up to 46 volts. Here the input 1 and the input 2, which you're going to give the command for this motor to work, and this is enable A. So I don't think I explained the enable in the other chip, but enable, when it's go high and you give high to the inputs, the outputs go high too. But if the enable is low and you give high to the output, nothing to the input, nothing will go to the output. So make sure this goes to low, so you can drive your motor whenever giving an order to the input. Now this is going to ground. Now the logic supply voltage VSS is going to be 5 volts because the chip works in 5 volts. Here is the same input 3, input 4, and here's the enable, the second enable. As I said earlier, in this enable you need to be high so you can drive your motor. Now let's see this one here. So this is half, as you can see, it's half 0.5. This is actually half the L293D. Sorry, HAL the L298N. So let's see here. You have your VCC, your VS, and your motor. Here is the sense pin. Here is small resistor, and here you can control your circuit. So as I said, if it goes if it goes super hot, so the motor drawing more than 2 amps, the circuit will be super hot and you can damage it. So make sure, if you don't know, if you're using a big motor that draw more than 2 amps, you need this. But if you're just using a small AC card, so you don't need to worry about this. Now if you notice, there is 4 diodes here, because the annoying thing about this chip that it doesn't have a freewheel diodes in it, because if you're I'm going to explain this. If you don't know the coil, it's just, you know, the coil, because if you're going to give it a voltage, then you accidentally stop that voltage, it will actually give a voltage in the inverse direction. So here we have a motor that it have a coil on it. So let's say you have a big motor, big coil. So if you're going to give it a big voltage, when you accidentally, or you want to stop it, so you cut the voltage on it, there is a voltage in the coil, it won't to go out, so it will be in this direction, and whoop, it will burn your chip. So you need 4 diodes. You better have a Schottky diodes, but I use it a normal diodes because I didn't have a Schottky. It works fine, but so far, so you better have a Schottky diodes. And just you have 2 motors. In every motor you have 4. You need to set 4 diodes. So let's review it again. You have here, you can put either one of those, ground or resistor, or 2 small resistor. Well, it's more invalid, but actually it's quite big because it's a 2-watt resistor. Here you have the output, which you're going to wire to motor 1, motor 2. Here the VS, your motor supply. It can go up to 46 volts. You have input 1, input 2, enable. You need to make sure that the enable is high so the motor works, and you can actually use this for with pulse width modulations, because you can, if you have a microcontroller like an Arduino and you put in one of the pulse modulation pins, and let's say you put 15, so you can here change the speed of your motor, or you can just permanently put it to high, so whenever you give a command 1 logic to the input 1 or input 2, it will work. Actually my PC is running out of power, so there you go. So here is the ground, here is 5 volts, and that's it. So it's not that complicated, isn't it? I'm going now to show you a small demonstration, and I'll be back. as you can see here, this is the chip. Those are the two resistors. Here I put it a 5 volts regulator, the 100 nanofarad capacitor here, and one is here. The 4 diodes. Here I have 10k resistors, pull-up resistor. Here the 2 channel of the motor, the motor voltage, the IC voltage. Here I have a heat sink, but I just didn't put it in because actually this chip is burned, not burned, half of it is burned. I think it was bad made it, no, bad made chip something, because half of it work, the other half don't work. Well, it's not my fault, it's not like I burn it or something, I just buy it, don't with buy it already, it doesn't work. So here I have a wheel, and I'm going to plug it here because I'm going to use the half that is already working. So as you can see, working this direction. Now in the other direction, as you can see, direction 1, direction 2, and this is the chip. Now let's talk about which one you should be getting. Well, I'm sure after seeing this you might be asking yourself which driver I should be using. Well, it's actually simple. First, check your motors. Use a voltmeter, actually ampermeter, and check how much current your motor draw. If it's under 1 amps, like this small motor, I put it in serial with my multimeter, and I just like this with my hand, and it only draw about 300 milliamps, so it's okay, I can drive it with my L293D. But this motor, it actually drive around 1.7 amps, 0.7 or around 5, I don't know, but it's actually more than 1 amp, so I cannot drive it with the L293D. Well, I can, but it will not work at full potential. So first, check your voltage, how much you're going to give it. If it's more than 36 volts, you need to use the L298N. Second, check the current that your motor draw, and L293D against the L29N, what are you going to choose? And one important note, put in mind that those two chips aren't MOSFETs. That means you're going to face a voltage drop. If your motor is drawing too much current, there is around from 1 to 3 volts voltage drop. It might not be big if you're using a big voltage like 14 volts or so, but if you're using 5 volts or something and you have 3 voltage drop, you're only going to deliver 2 volts to a motor. That's really, your motor will not work. So for this you can use a MOSFET transistors. You can build your own motor driver. I'm going to put some schematics using NPN and PNP. Actually, that's for transistor. For MOSFET, there is P channels and N channels. If you wish, I can make a video on it. Just, if you like the video, you can just hit thumb, subscribe, and maybe a comment, so I know what you think about this video. If something you didn't like, or you think it's too tall or too short or something, I hope you can leave it in the comments and I will reply you back as soon as possible. So peace and stay creative.